Hello there, Mr. Chu here with Bear Algebra, teaching algebra so that everyone understands and learns. This is a second section on the same topic of understanding variables and algebraic expressions, so it has a little bit more difficult examples than what the first one did. There will be links to that first one if you need to see it at the end. So we went through terms and we talked about variables being letters of the alphabet, either the English alphabet or the Greek alphabet. And then we talked about the variables being lowercase letters as a rule. Then the algebraic expressions, two more variables, numbers that can be added, subtracted, multiplied, or divided. Here's some examples, just x, 3y, negative 13m, the symbol pi, and the symbol alpha. Here's some expressions, x plus 4, 3y minus 7z, mn divided by fg, and negative 12bcd. So a term in an algebraic expression is just one of the variables or numbers. So in this first example here, the x is a term, the 4 is a term, the 3y is a term, negative 7z is a term, mn is a term, fg is a term, and negative 12bcd is a term. Two or more terms multiplied together is called a factor, and the result of multiplication is called a product. Product can be expressed by using two variables side by side or by using an asterisk between two numbers or variables, a raised dot between them, or a set of parentheses around one or both. If we want to represent the products of m and n, we can do it several ways. Just write mn, m asterisk n, m raised dot n. We can put parentheses around the m and not around the n, or around the n and not around the m. And then you could put parentheses around both of them. So remember, when you're writing algebraic expressions, you're looking for words. The word more than, some, plus, increased by, or added to. Then you're going to use the addition property. If we have the word less, difference, decreased by, or minus, you would use the subtraction property. If you have the word multiplied by, times, product of, or just the word of, then you would be using multiplication. And if you have the word divided by, quotient of, you would use division. So this is just a very important background situation here where you have to understand this to move forward. So if I want to write 6 less than 4 times b, you have to think in your mind, what was less than mean? And it's not an inequality sign, it's subtraction. So 4 times b would be written as 4b less 6 minus 6. You would not write 6 minus 4b. It's 4b minus 6. For example, 3b, 3 times the difference of 5 and c. So we're going to write 3 and then times b multiplication. Here, this one's a little bit harder. Difference of 5 and c. We have to take and have a difference of 5 and c, which is 5 minus c, but you're going to have to use parentheses around that. So 3 times, that 3 goes out in front of the parentheses, inside 5 minus 3. You could put the 3 over on the right, because it's going to give you the same answer. And in the next section, I believe it is, the next lesson, we will be talking about what property this is called. Then on example 3c, 1/4 the cube of d. We write it like a fraction. That's the way most teachers would prefer that you do it. 1/4 cube of d would be d cubed. And that kind of pulls in the exponents and the powers like what we had talked about in the second example from lesson 101A. Let's talk a little more about power So a power is an expression that's written a base raised to an exponent. So the n is the exponent in a to the n power. And the a is called the base. So in example 2, it says identify the exponents and the bases of each power. So if I have the pi symbol, that's my variable, raised to the 4th power, the base would be pi and the exponent would be 4. If I have negative 19, a to the 4th, b squared, the negative 19 is called a coefficient, but the a is the base, 4 is the exponent. B is the base, 2 is the exponent. In this next example, we have 14 beta raised to the 3rd power. So the base of 14b with exponent 3. Now this 2 ends up being the coefficient in 2 m to the 9th n to the negative 1 p to the 0th. But something else is going on here that we'll talk about here in a minute because it's an important algebra lesson. 2 would be called the exponent and m would be the base with exponent 9. Then n would be the base with exponent negative 1. But what does a negative 1 exponent mean? It's something that should have been covered in a pre-algebra or middle school class before you were taking algebra, but we will review it because it's very important. And then the p is a base and exponent of 0. What is a negative exponent and what is an exponent of power 0? So this is very important and we need to discuss it. So what do they mean? Well, it's pretty obvious that we need to develop it. So let's look at a pattern and try to figure it out. So we can use a pattern of 2, not 2 to the n, it's raised to the power of n. So that was a typo. This n is up here to the power. It is not down here. So it is really 2 to the nth. And now we're going to substitute n equals 3, 2, 1, 0, negative 1, negative 2, and see if I can come up with a pattern. So let's do it and see what happens here. So 2 to the 3rd power means 2 times 2 times 2. That equals 8. Now let's go down. We're going to go n equals 3, 2, 1, 0, negative 1, negative 2. So 2 squared is just 2 times 2. It's equal to 4. 2 to the 1st is just 2, just one time. Now, to come up with 2 to the 0th, we have to come up with a pattern here. So let's see if we can figure out some kind of a pattern here. So from 8 to 4, what type of an operation would you use? Well, either you subtract 4 or you divide by 2. So it's either subtract 4, I'll just write sub 4, or divide by 2. Now we're trying to find a pattern here. Okay? So now let's go from 4 to 2. You either subtract 2 or divide by 2. Ah, we divided by 2 in both of them. Now let's see if we can get that same division by 2 in the next one. So if I take and divide 2 by 2 to use that same pattern, what would that equal? 2 divided by 2 is 1. So that answer would be 1. Now take 1 and divide it by 2. 1 divided by 2 is 0.5 or 1/2. And then 1/2 divided by 2 is the same as 1/2 times 1/2, which would equal 1/4. So just to sum it up, whenever you're dealing with negative exponents, any number to the negative first power would be that number over itself to the first power. So 1 over the base of 3 would be in the denominator, raised to that first power. So if I have 4 to the negative second, that would equal 1 over 4 to the second, which equals 1/16. And then anything except 0 raised to the 0th power will always equal 1. Now, those really are 8th grade standards, and I wanted to review them in this understanding the exponents part of this lesson. So that's a little bit more advanced than what the first lesson's problems were, but it is necessary. So try these problems on your own on a scrap of paper. There'll be a video link at the end of the solutions of these problems. So write algebraic expressions for each verbal expression. The sum of 4 times k plus k and 6, the product of y to the 4th power and z to the 3rd power, the quotient of 7 times b squared and 2, 6 times the sum of the cube of m less 2. So you could pause if you would need to write these down, see if you get them right, click on that other link and see if you did them just as we would want you. Student practice problem 2. A is 16 to the 3rd power. Identify the base and the exponent of each power. B would be negative 20p to the negative second. And C would be 2 pi r squared. And then D would be A to the negative 1, B to the 0, C. And if you want to extend this and then go a little bit further, simplify these 4. So a link will appear over on this right side here whenever the video's over that you can click on and you can see the solutions of these powers. There will be also another link that will come up that will be a link for the first session. There will be a playlist here also for all of Unit 1. Make sure that you subscribe to my YouTube channel and follow me for more helpful Bear algebra videos. I do look forward to working with you as we learn more and more algebra. Thank you, and I will see you in the next lesson.